Hello everyone, this is going to be episode 7 of Microeconomics on Instagram, and today we're going to be talking about short-run costs. So some of the core concepts are elucidated right here. So in the short run, we are assuming one input / factor of production is fixed. Remember when we did for production functions on Monday, we talked about total marginal product and marginal product? Well, that's obviously going to be very relevant when we're talking about cost curves today. So in the short run, we're assuming one factor of production is fixed. And so in our example specifically, as you can see over here, we worked with thinking about the cost curves of Starbucks. And in this specific example, we're going to hold capital fixed. And the way that we think of capital, remember the definition of capital is wealth used to create other wealth. So we're thinking of the actual physical Starbucks restaurant, the electricity bill, the espresso machines. That's what we should conceptualize when we think of capital. And it's more realistic to hold capital fixed in the short run than labor in the short run. Both are very important inputs in the production function. And so we're going to assume labor is variable. It's going to be the variable input in the production of Starbucks coffee, and capital is going to be the fixed input. And so here we can see that since it's variable, labor, we should expect the, as you can see here, I put differences, there's different types, or there's different numbers of baristas, right? And different possibilities, right? That's what's going to give us our cost, functions, and our cost curves. And so we see that the actual production of coffee per day increases. There's not negative total product, but there definitely could be negative total product, and we would expect negative total product at some point. But we are able to see pretty early on diminishing marginal product of labor, which is one of the second core concepts, right? And it shows how production functions are very related with cost functions, or inversely related, and we'll see in a bit with cost functions. So we calculate diminishing marginal product of labor. Remember I said the term marginal, think of additional twice. So we talked about marginal utility when we were going over consumer theory and marginal benefit. So marginal utility, the additional utility that from an additional consumption of a good, and then marginal benefit, the additional benefit from additional consumption of a good measured in dollars. Marginal product here is going to be the additional product from an additional unit of labor, right? Using additional twice. Get that in your head? So the gap is 80. So that's the marginal product. So I'm calculating marginal product. And the gap here is 120. Gap here is 60, 40, 30, and 20. Right? And we can see early on, as we added the second barista, the production or the total product more than doubles. So we don't have diminishing marginal product of labor yet. Diminishing marginal product of labor doesn't necessarily have to kick in right away, but it certainly does kick in at the third unit of labor, where 60 is obviously smaller than 120, and then all the way down we have diminishing marginal product of labor. In the short run, we should expect diminishing marginal product of labor. Think about it. If you have capital fixed, you can't make another Starbucks, you obviously aren't going to try to expand production by hiring 100 workers. That's unrealistic. Okay? And then the fixed cost reflects the dollars per day. We're going to conceptualize the costs, we're going to conceptualize the cost in terms of dollars per day. And so the fixed cost is going to be $40, and that's probably not a very realistic number. But think of it as like the electricity bill, the cost of, the capital, like renting out the physical Starbucks. That's what we're going to see as the main fixed cost, or maybe the cost of renting out the capital equipment, the espresso machines, whatnot. We're just going to say $40 a day. And fixed costs do not vary depending on output. So you can be very successful at producing a lot of coffees per day, or not very successful. Fixed cost is not going to vary. Now, variable cost does vary with output, right? If you want more output, you have to add more costs. You have to increase your labor, and that's what this shows, right? So variable costs, we're just going to assume, because the numbers are easier, that 1 day of work per barista is going to increase the variable cost by $12. So this would be a linear relationship. Then total cost is the sum of fixed cost plus variable cost. Marginal cost is an interesting figure. It's the change in total cost over the change in output, right? It's interesting because marginal cost shows the rate of change in total cost over output. It's an interesting measure, and it actually, as we'll see shortly, has an inverse relationship with marginal product of labor, meaning as one goes up, the other goes down. And then we have average variable cost, which is going to be variable cost over output per day. Average total cost is going to be total cost over output per day. The reason why we care about these cost curves the most is because we obviously want to, when we said we were talking about optimal decision making at the beginning of the year, we said that rational producers and rational consumers think at the margin. So we obviously want to understand our costs as they relate to each incremental unit of output. And marginal cost is a very important measure for that. So then when we actually graph these curves, or before I get into that, we can see at unit 3, the third unit of labor, we get something special that happens. So at the same time that we're getting increasing marginal product of labor with the second unit, we see that we get decreasing marginal costs, decreasing average variable costs, decreasing average total costs. Then when the third unit kicks in, we can see that these numbers start to increase as diminishing marginal product of labor is taking in. So this reflects diminishing marginal returns. This idea that increasing an additional unit of input increases total output by less than the previous unit of input. Or specifically, we should think about it, it makes sense because if you're hiring additional workers and the cost function, the variable cost function is linear, but they're less productive, you should expect your costs to rise, which is exactly what we see, an inverse relationship. And then finally, Julie, if you can come over here so they can see these. This reflects a graph of dollars per cup of coffee, and then output per cups of coffee. So I graphed marginal cost, average variable cost, and average total cost. And then so you can see here, marginal cost goes up. And so this, we can actually divide it into two parts. So this part, or this is probably a more effective marginal cost curve. So this little handle of the umbrella doesn't have to exist. And it doesn't exist if your diminishing marginal product of labor kicks in right away. But because it does exist, we get initially a curve with negative slope. And so we see actually increasing marginal returns initially. And then the second part of the function, where we see marginal costs start to rise, that's where diminishing marginal product of labor starts to kick in. And that's where we expect diminishing marginal returns. Right? Average total costs, we see it comes from a very high point, and the thinking behind that is because we have to think of what comprises total cost. It's fixed cost plus variable cost. And so the fixed cost is $40. So initially, that's going to be a significant gap between average total cost and average variable cost. But that $40 starts to get divided by increasing units of output. So if I actually looked at average total cost, or average fixed cost, if I graphed it, which is a less relevant figure, it would hug the x-axis. It would be called, remember in Mr. Pacina's class, what is called a horizontal asymptote. Right? It would actually hug the x-axis because you would just be dividing that $40 by increasing units of output. And so as you're moving further along the x-axis, it becomes less a relevant figure, and an ever smaller, the gap between average total cost and average variable cost decreases, which is exactly what we see. Also, lastly, once marginal cost crosses average variable cost, it starts to pull up average variable cost. So it's going to cross it at its minimum point, and then it's also going to cross average total cost at the minimum point, which is exactly what you see here. And then finally, we talked about this. The area above average variable cost is the short run supply curve. because you wouldn't want to produce anything below your average variable cost. That would be shut down area. And the area above average total cost is your long run supply curve. Okay.